Hi everyone, this is Charishma from Triply Department and I'm dealing with the subject of database management system for current semester. So let's take a brief account of unit number 1 for 1 hour session. So in this session, we'll be looking into the concept of the basics of database management system, why we should go for a database management system, and what are the benefits of maintaining a database over a file system, and what is meant by the view of data and what are the different models we have in this database management system. And coming to the end, we'll be looking into the overall system architecture along with an important concept of view of data, which means it would be looking into the concept of data abstraction. So let's see what each content carries about. So first one is in the introduction to DBMS. So before going into the details of DBMS, we need to know what is meant by a data and what is the difference between data and the information, what is meant by a database. So when I say what is meant by data, so it's nothing but a raw fact which has been unprocessed and unorganized. So that means you're just collecting the facts that is present and you're making a record of it and you're not imposing any kind of mathematical relation over it to get a resultant or a desired output. So you're just collecting the facts and making a record of it. Any that kind of fact is called as a data. What is meant by information? So let me explain this concept with an example. You assume you have collected a set of values and you're trying to find out an average of those set of values. So what you do at this level, you apply a mathematical relation for to find out the average, and then using that mathematical relation you will be getting an output, one single output for a set of values. This output what you attain by imposing a formula over a set of values is called as information. So here the information I can call as average in our example. So that's what it says. Information means processed form of raw facts, that is data. Okay, let's get into what is meant by database. So database is nothing but the collection of data in one particular location. So you're trying to, just now I said, you'll be collecting the raw facts and making a record of it. So where the place where you're placing or storing the collected raw facts is called as a database. So why you need a database? The concept is simple. So if you're trying to collect a data or raw facts and storing in one particular location, so it would be easy for the user to retrieve the data whenever he needs and obtain information from that particular data. Okay, so in this particular present scenario, when I speak about database, by default, you usually store your data in the form of rows and columns. You usually proceed in this manner to store your data. So, of course, you have different means of storing the data, but the most profound way of storing the data is in the form of rows and columns, which is nothing but a table. So when I combine rows and columns, it means you're forming a table over there. So next slide. So why we need a database is your next question. So when I know what is my database, the next one what I need to know is why we should go for a database when you have other means of storing the data. So the answer is simple. The first one is your mass storage. So if you maintain a database, that means database in the sense if you're trying to store the raw facts in one particular location, you would be able to store even the gigabytes of data at one particular location, which may not be that possible with other programming languages like C, C++, Java and all. So that's why you have a separate scenario called as maintaining a database, because you can actually deal with a huge amount of data storage and data retrieval process. And next one is removes duplicates. So there's no chance of maintaining duplicate records in this database. You can maintain a unique data. So no repetition of data usually is encouraged in your database. So main the I can say like this is one of the most important uh, as applicate like a most important use of maintaining a database, that is maintaining a unique information. So next one is security and protection. So this is another main aspects. So if you're storing your complete data in one particular location, you would also be able to put some restriction codes so that only the authenticated users can access the data. Restriction code in the sense like how you have a username and password for entering into your account for any application. So you when you enter a valid username or password, then you are an authenticated user who can access the data from that particular application. This is the way I can the thing can be explained in a better manner. So when you maintain a database, so this assures you that your data is much secured and protected. Okay. The next one is multi-users. So it's like not only a single or one or two users can access the data at a time. In fact, if you are dealing with a database, more than multiple, like more than one or two persons can access the data at a time at the same at different location. This is the main aspect. So you can access the data at a time from different location is one more advantage of maintaining a database. So let me make the points very simple. So why we should go for database? So it's because of because it helps in maintaining mass storage and removes duplicates, security and protection. Last one, it encourages multi-users. Let's get into the next slide. So where we usually find this database application. So in this slide, though I have marked around 5 applications, but in fact in your day-to-day application, the database can be found at many number of locations. So you hardly find a place where you're not dealing with the database. Can take n number of examples from in one so the point where you wake up and so in complete day you might be coming across different applications or different examples of database. Okay, so let me take the main applications where you are going or dealing with the database in day to day. So first one is your banking. So, in fact, if I say the banking is maintaining a huge database of for its customers, in fact, each is maintaining an account for each and every customer, and it is dealing with all the transactions that is made by uh, its customer. So you can imagine how many each and every person is holding his account, and this bank is taking care of an account in the form of a database for each and every individual. Second one is your airlines. So what the airline speaks about is all about reservations and schedules, departure times, and what are the discounts that has been given for each and every individual. So what is the travel history of each and every individual or a customer of that particular airlines. So next one is university. I think this is this can be understood in a well detailed manner by we people. That is when I speak about university, so it would be again maintaining the database of each and every student who has been studying right now, and also the records of its old students. So what all records that a university possesses. So it can be about the marks of the students, registration numbers, and what are the fees payments that has been taken care by the students. So all those aspects is being maintained by a university for each of his students. Okay. Next one is e-commerce. So I think this will also give a profound applications. The first one, e-commerce. Right now, we many of you are dealing with different types of e-commerce websites like Amazon, Flipkart, and all. So again, here these e-commerce websites are dealing with the huge number of customers. So again, maintaining a database of each and every customer regarding his purchases made, what are the products, and it would be again suggesting the new products based on the history of purchases done by that particular customer in that particular e-commerce website, etc. And what are the it would be offering a new discount. So how is it happening? It is actually based on the database that is maintained by the e-commerce website for each and every customer. And then coming to human resource, like if you are working for an enterprise, and it again each and every enterprise is should be maintaining the record of its employees regarding its salaries, tax deductions, and many others. So, what promotion details, etc., and etc. So, these are the main applications what we find for a database in day-to-day life. Okay, so in fact, I can simply say what is meant by yeah, let's get into the concept of DBMS. So, what is meant by DBMS? DBMS is nothing but database management system. So, once the topic of database is over and why I should go for database, so when this point is clear, next the thing that should strike our mind is about what is meant by DBMS then. So you see, when I'm storing the data in one particular location, in that case, I should also need a means of dealing with this data. Means of dealing with this data means I need a tool through which I can manage the data that has been stored in one particular location. So the tool what I'm speaking about to manage the data is nothing but the software. So you're using a software to process the data that has been stored in a location. So let's read the sentence. It is a software. What is meant by DBMS? It is a software used to process the data or a database to give an appropriate or required information. Okay, so in the previous example, when I was saying you're storing the raw facts and you're trying to derive or determine the average value from a set of values. In that case, I'm applying an average relation. So how is that I'm applying an average formula over a set of values using a tool called as using a tool which I can say about the database management system. So I'll be having different types of softwares through which I can write my code to determine the average for a set of values. So when I write the code through some tool or through some software, that is nothing but database management system. Okay, so different examples, your pretty good examples what you find for database management system are Oracle, SQL, and MySQL. So I think Oracle has been used in a few years back, and now SQL is playing its role in database management system. And this SQL would be dealing with the form of storing the data in the form of tables. So this is a kind of software what we are using in present days. So next one, let me yeah, this is the better quote what we can give for the database. So actually this database touches all the aspects of our lives. This database touches all the aspects of our life. So why? Why reason is it's a recording of facts at each and every instant is what that has been done always. You see, at each and every moment we are trying to note down the facts. So this noting down of facts and storing in one particular location, that's what is nothing but the database. So how many types of database we actually have? So you can see many types of databases on the screen, like how you have a centralized database, distributed database, relational database, NoSQL database, cloud database, object-oriented database, hierarchical database, network database, personal database, operational database, and enterprise database. So, in this present unit, you will be only looking into the concept of relational database. For additional information, I have gathered all these names. But in this unit, you will be, or in this particular semester, we'll be only looking into the concept of relational database. So what is meant by a relational database? So relational database is nothing but storing your data in the form of tables. So I can say in the form of rows and columns. So this rows and column is nothing but a table. Okay. So yeah, let me skip this one and directly look into the relational database concept. So that's what I have said just now. Relational database nothing but the stores data in the form of rows and tables. What are the different examples of relational database you have? MySQL, Microsoft SQL Server, and Oracle. These are pretty good examples what we can find. Okay. So next, what is the purpose of database system? Okay, let me like how I have said what are the why we should go for database management systems or why I should go for a database. In that case, I was speaking about mass storage, it removes duplicates, and we have a security and protection aspect, and more than one user can access the data. So these were the points what we have discussed just now. And apart from this, I also have to explain you this database management, the purpose of database management system with respect to file system. So it's not like when we have different languages, C, C++, Java, and all. There also you are capable of storing the data. That's fine. Then why, when you are able to store the data with using those languages also, then why should I go for a database system specifically? That is a question. When the storage means is available for C, C++, Java, why should I go for a database system? Okay, so the reasons are first one, data redundancy and inconsistency. So what does it mean? You see, data is of many different forms. So it's not like the data is only in the form of letters. So the data can be in the form of digits, data can be in the form of videos, data can be in the form of images, whatnot. There are different modes of storing the data, different means of storing. So it's not like when I deal with file system in C, C++, Java, dealing with different file formats is very difficult there. So to overcome this, so this database management system is helping me to store the data of different file formats very easily. That's what it says. So this concept of database management system is overcoming the issue of data redundancy and inconsistency. The next one is difficulty in accessing the data. Difficulty in accessing the data. You see, when I deal with a database, or if I want to retrieve some kind of data in a database, so I can use a tool or using it, for example, I can proceed in SQL. I just write a simple piece of code and I would be retrieving the data what I want or access the data what I want. But the same piece of information, if you are trying to gather using C, C++, or Java, you may have to write a new program to carry out new task. New program in the sense the program writing would be carrying out in a huge number of lines, and debugging that program and making your task done is much complicated in C, C++. Whereas in your DBMS, you always have an inbuilt code in the database engine. And if you write a small 1 to 2 lines of code, depending upon your commands, what you give, the compiler would take the remaining action to give you the information in a few seconds, I can say. But in your C, C++, and Java, they're writing a code for each and every task itself carries enough time. So that's why we say it's much difficult to access the data in file system. Then coming to integrity problems. So what are the integrity problems? So you have to put constraints for each and every step. Like if I'm writing a code for an account balance, you may have to fix some constraints, like account balance should be greater than 0. This is one constraint what you want to fix. So if in case you have already fixed your constraint for your data storage, and if you want to make some changes or add a new constraints to the existing one, the program would be, you have to, I already said, for each task you have to write a new program, and for the new program may disturb the existing program and make your complete data storage system in a clumsy way. So instead of that, if you are maintaining a database and if you're proceeding with a language called proceeding with dealing with your data in DBMS, so you would be fixing your constraints at the basic level itself. So this concept will be explained in much detailed manner in coming slides. You'll be fixing the constraints at the basic level itself. And if you want to make any changes or simple commands, you have few set of simple commands, and using those commands you can make your work done very easily. Okay, so next one, atomicity of updates. So I can explain this concept better with the transfer of funds. I'll take an example. So you have two accounts, you have two accounts, account number 1 and account number 2. So you assume this account is carrying some 2000 rupees, and account number 2 is carrying some 1000 rupees. And you felt like you want to send some 1000 rupees from account number to account number 2. So here I would be writing, if I speak about file system. In file system, I may have to write code for first deducting the amount of 1000 rupees from account number 1 is the first step. First, I have to write code for deducting the amount from account number 1, that is 1000 rupees. And second step is about transferring the amount of this 1000 rupees into second account. And third, I may have to proceed with addition of amount, this 1000 rupees, in account number 2. So I may have to proceed writing code for all these steps. And if I faced an issue like among these all three steps during the transaction, you assume the third step has failed. Third step has failed. Third step in the sense adding 1000 rupees into my second account is my third step. And if that step fails, it happens like this particular 1000 rupees has already been deducted in account number 1 and not has not been credited in account number 2 because the third step has been failed. In this case, we don't have a proper data regarding where this 1000 rupees exactly gone, because the first step has been executed, that is 1000 has been deducted, but this 1000 has not been credited to second account. But there's some issue regarding where this 1000 rupees has gone. So usually you find this kind of atomicity update or atomicity of updates issue in file system, whereas you can overcome this issue using database system. For example, if you're speaking about database system in the same case, if my third step has failed in database system, you assume my third step has failed in database system, what happens is it bounces back, it rolls back to its initial stage. That means if the third step is failed, this 1000 would automatically gets refunded to the account number 1. So this atomicity of updates issue has been overcome in database systems. And then last one is about multiple users, like how I have already said, more than one user can access the data, like all the authenticated users can access the data at any instant, at any from any location. So database system offers solution to all the above problems. So what are the problems? Let me put in glance. The first one is data redundancy and inconsistency, difficulty in accessing the data isolation problems, integrity problems, and then is atomicity of updates, and then concurrent access by multiple users. So all these issues has been addressed and has been overcome in database systems. Next one is a concept of view of data. So what is meant by view of data? So let me introduce a term over here is about data abstraction. What is meant by data abstraction? You see, when you have huge amount of data stored, or for example, let me tell, our institute is maintaining a huge amount, a big database of all its employees, staff, employees, students, and a separate database for each and every department. It's not like when being a faculty, if I want to access the data, it is not showing the complete data of the institution to me. So what exactly is it showing? It is showing only that particular data which is relevant for me or required for me. So that's what. So what is happening? So how is this filtration happening? So when the institution is maintaining huge data and there's some filtration happening in between, only the relevant data is being shown to me, and all the complex data or the data which is not required for a faculty is being hidden. So that process of filtration that is happening in between is nothing but the data abstraction. Similarly, if a student want to access the data, only the relevant information of the student will only be displayed. For example, a student, what data actually a student requires, he or she requires only the data of his marks and the data of the fee that has been paid by him, and what are the examination details like library details. So this is the data what exactly need by a student, and only that set of data will be shown to the student, and remaining data will be hidden from the student. So this hiding of irrelevant data from the user is called as the data abstraction. Like how you see the sentence says, data in the database are stored in very complex structure, and what is being is you see here, database shows only useful, required, relevant information to the user, hiding the complex information like structure, organization, retrieval, and steps and methods. Okay, so this is a process of abstraction. So what is meant by, so I already said to explain this concept of view of data, you may have to look into data abstraction and the other concept called as instances and schema. So what is meant by instances and schema? So an instance is nothing but determining your data status at one particular instant of time. So you see the data is not a static in nature. So data is always dynamic in nature. Its values and its data stored inside keep on changing from time to time. It's always dynamic in nature. In that case, what we have to do is we may have to determine the data status at one particular instant of time. So what is the data state? If you're being a manager, especially speaking about banking sectors, the data would be changing from time to time. Data of its customers would be changing from time to time. Why? Because there are huge number of transactions happening by the customer time to time. At that instant, being a bank manager, I would be asking to bring out the data instance of one particular customer around time of 10:30. So what is happening? So this DBMS would be pulling out the data that has been updated till 10:30 a.m. And can you assure me that this value remains same at 11 o'clock? The answer is no, because the data is dynamic in nature. The transactions made by that particular customer would be changing at 11 a.m. and this bank manager is asking the data of a particular customer at 10:30, which is nothing but an instance. That is nothing but the actual content of the database at a particular point in a time. So the data at 10:30 is said to be the data instance at 10:30 a.m. 10:30 a.m. Then what is meant by schema? Schema is nothing but the blueprint. I can simply say it's like a blueprint or a logical structure of database. So before proceeding into your database design, you may have to do some groundwork. So what is that groundwork makes of? So what is your requirement? What are the tables that has to be created for the data and what should be the column names for each and every table and what type of information has to be gathered in the database. So type of data, whether the numerics or alphanumerics, so what type of data should be accepted by each and every column. So you have these many elements that are to be addressed at the ground level. So for that case, you usually design a schema or a groundwork what you do or the basic work or basic structure what you plan to proceed with before designing your database or before starting the work of constructing a database. So let me put things in simple. The schema is nothing but the logical structure of database, or you can say the blueprint of the database that is happening at very initial level before constructing the database. So this happens at very initial level. So once this is over, so I have to take an important concept of um, data levels of abstraction in database. So what are the different levels of abstraction? Like already said, abstraction is nothing but the filtering out of data. So at how many levels this filtration of data happens is the question. So usually you have three levels of abstraction. The first one is physical level. The other name of physical level is internal level. So what happens at the internal level? So at this internal level or a physical level, the schema design happens. And this at this level, the filtration of data happens at very minimal level. The schema level, there's no data has been inserted right now. In this case, you don't have much data to be hidden. So when the data has to be hidden, when the values are inserted into the tables. But at schema level, you don't have any values inserted here. So therefore, the filtration is at very minimum level. That is, the schema design level is called as the physical level, where the data abstraction would be very minimum. Then coming to your logical level. So when I speak about logical level, at this level, you would be inserting the values inside the table. You would be inserting the values inside the table. So once the values are inserted, there are few data. If in case some data wants to be hidden by from the programmer. So in that case, there's some set of course that will be developed by the data admin to make the information, to decide what information to be kept visible for the programmer. So who is going to insert the values? It's the programmer who is going to insert the values into the table. And if this data admin feels like this information is very sensitive and this should not be revealed to the programmer who is working on the database, in that case, so data abstraction can be done. That means filtering out the data. How you filter out the data? Here again, you write a few code lines to keep the data filtered out. This data will not be visible to the programmer. He'll be working on only those aspects which are being given permission for this programmer to access with. Next one is view level. So this is the level where we are looking into. So if an application has been designed and the database has been linked up to that particular application, and you are the user who is going to access the data, so your accessing the data is at the view level. So first level, only data admin would be deciding where the schema has been designed. So this admin will have the access to the complete database, irrespective of whether the data is sensitive or not. This fellow has access to that complete data of the database. Next level is your logical level where the programmer would be working and this data admin would be filtering out few sensitive data from the programmer, and this programmer can see only some relevant information based on his requirement. And the last level is your view level where each person or each user would be having a different access to the data, like how I have given an example. Being a faculty, I would be accessing some set of data. Being a student would be accessing some set of data which is relevant to him. In that case, each type of user has a different view of data. That means the highest level of abstraction happens at the view level. Highest level of abstraction happens at view level because depending upon the type of user who is accessing the data, the filtration happens at a rapid level. So that's what it says. It's this is the top level of abstraction, and there are many different views of the same data. You see, there are different types of views that has been provided. For example, if it's a college database, HODs would be having a different view of data. Student would be having a separate view of data. Faculty is having a separate view of data. So this is a simple architecture of database system with three different levels of abstraction. Next one is about database language. So what are the different database languages you have? So there are basically four different database languages. First one is DDL, DML, DCL, and TCL. So what is meant by DDL? DDL is nothing but data definition language. Just now I said there are different levels of database system or architecture of databases. The first level is your physical level where the schema is designed. This is what we have learned so far. But how is the schema designed? So this schema is designed using DDL language. That is, the name itself says data definition language. Data definition language, and this is used for designing the schema. Okay, so what does the schema actually means is it's all about creating the table, creating the views, and whatever the constraints you have, you will be fixing the constraints. Constraints in the sense the rules for storing the data. So if you have any rules to be taken care of while storing the data, so those rules will be set at the basic physical level itself using data definition language. So you're having, so we'll be having a set of commands for this DDL. So very important concept. First one is create command. Next one is alter, drop, truncate, rename, and comment. So creating in the sense you are creating the database using database in the sense it's a collection of tables. So you are creating a database or the tables using a command called as create. So when you create, assume here I'm creating two tables and I'm maintaining a database containing of two tables. So how to create the table using the command create. And what about alter? Alter is something which is used to make the changes at the schema level. So once the schema is designed, you start proceeding with the, inserting the values into the database. So in case while working or at the next level, you feel like there's some changes that has to be done at the schema level, you again come back and just make use command alter to make the changes in the tables whatever you have created at the physical level. Next one is drop. If if you faced a scenario like you want to delete the complete database or the schema that has been designed in physical level, you just use drop command and the complete database would be cleared. Next one is truncate. So truncate in the sense if you want to delete tables at one particular instance, then don't go for drop command, you just use truncate and that would delete the data for that particular instant of time. Next one is renaming. Renaming is nothing but the name what you give. If you feel like changing the name of the tables that has been mentioned in the database, you just use rename command. And last one is the comment. Comment is additional information what you can give for each and every table in the table database. Next one is DML. DML is nothing but data manipulation language. So once this is done, once the basic schema has been designed and the tables has been fixed, now you may have to enter the values inside the tables. Enter the values inside the tables. So how to enter the values or insert the values inside the table? That is using DML command. So let me make things much simple. So this DML is used to work on the tables. It's like inserting the table, modifying the values inside the table, deleting the values inside the table, whatnot. Everything inside any kind of action inside the table happens through DML. So let me tell you, there are two levels of DML. The first one is procedural DML and next one is non-procedural DML. Procedural and non-procedural DML. So what is this procedural DML means? You would be saying if what kind of what data you need. So you're not, if in case you need some data, you're not only saying what data is needed, you also have to mention how to get the data. That means you may have to write the code for retrieving the data. You proceed this way, you're mentioning, you're guiding the compiler to proceed this way, go for validate the commands and then again retrieve the data. You're mentioning the complete process of retrieving the data. And what is meant by non-procedural DML? Here you are only bothered about what data you need. Just mention what data you need and the compiler will look into the next remaining action of how to get the data. So here you're not going to give or write code for how to get the data. Just mention what data you need and remaining action will be taken care by the compiler. So if you say by according to the definitions what I have explained right now, it would be, I think it's pretty clear that non-procedural DML is much easier compared to procedural DML. So the best example what I can give for non-procedural DML is your SQL. Okay. Now let's go and have a look into different commands what you have for DML. What are the commands you have? Select, insert, update, delete. Select, insert, update, and delete. And what are the commands of DDL? Create, alter, drop, truncate, rename, comment. And coming to DML, select, insert, update, delete. So what is the select going to do? The select is going to select records from a table. So if you want a certain record to be selected, just use select command and just mention the column names. And then coming to insert. If you want to fix or set insert a few values inside the table, use insert command. And again, if you want to make any kind of changes inside the table, use update command, where in TDL it was alter, but here in DML it is update. And if you want to delete any record from the table, like you would be inserting values, right? So if any of those values want to be deleted, in that case you use command called as delete, and this delete will delete that particular record. Be very clear, it's not going to delete the table, it is going to delete only a certain record what you are mentioning in the command. Next one is DCL. DCL is nothing but data control language. So data control language, you have two commands, grant and revoke. So let me explain this concept with an example. So being a programmer, I am working on a database and I am going on leave for 2 days. And in this particular database, I am the only person who has been accessing the data, and I am the only person who is authenticated to work on that data. And when I go on leave for 2 days, I may have to give the access or permission for the other person to work on that particular database in my absence. In that case, what I do is I just use a command called as grant to give permission for the other person to work on the database in my absence. And once I come back, I would be using a command called as revoke to get back the permission. And now I'm the only user who can access the data. The next one is transaction control language. So transaction control language, you have again two commands, that is commit and rollback. So what is meant by commit? Commit is nothing but to make the changes permanently. So you made some changes in the database and you want those changes to be in the database for permanent. In that case, you use commit command. So your data or the changes what you made in the database would be stored or saved forever. And if in case you felt like the last change what you made is having a flaw or carrying a flaw, there is some mistake that has been done by you while saving the changes and you gave a commit command. So in that case, what to do? So this commit command I already said would be changing or making the changes permanently. And if in case you made a mistake in your last commit command, so you can use rollback and make the changes and again use commit. So you be very clear, this rollback will work on only last commit statement, only last commit statement. Though commit give may saves the changes permanently, there's one provisions that has been provided by DBMS, that is rollback command, using which you can make or rectify the mistakes that has been taken care in the last commit command. Next one is about data storage and querying process. So you can divide the database system into storage manager and query processor concept. So what is the storage manager going to do? This storage manager is responsible for interaction with the file manager. So let me make things simple. It is responsible for storing, retrieving, and updating the data in the database. So this is the main aspect. So the complete database system, you are just dividing it into two elements. One is storage manager and next one is query processor. If I want to make things very simple for you, data storage manager will be looking into the concept of storing, retrieving, and updating the data in the database. And the this query processor will look into the codes what you write, for simple codes what you write, and it would be validating the codes and giving the command to the compiler to proceed with the action of execution. It will be cross-checking the codes with the inbuilt codes in the database engine and would give information to the compiler to proceed with the action of execution. So these are the main concepts of unit number 4, unit number 1 that we have discussed. And in the coming unit, we'll be looking into the concept of elements of relational database. I already said relation is nothing but a table, and we'll be looking into each and every aspect of a table. What is meant by a table? So what are the different elements of table? What is meant by a key? What is meant by cardinality, degree? Many important concepts would be covered in unit number